Alright folks, today we're working on 9.2, which are logarithms. So we've seen 9.1 had exponential functions, we've seen equations, well, we've seen things like 2 to some power equals a number, and 3 to some power equals a number, and 64 to some power equals a number, and we've graphed those, and so we've had a little experience with exponentials. So let's talk about what logs are for. So we would see a log if we were trying to say, hey, let's put an x right here. So let's say 2 to some power equals 4. So where our output is 4, we have an intercept of 1. That doesn't really matter a whole lot though. So we're saying 2 to some power equals 4. Well, x has to equal what 2 multiplies by itself how many times? So 2 times to the first power is 2. 2 to the second power is 4. So we can just say x has to equal 2 because multiply 2 by itself 2 times you get 4. So by the comparison logic, we're saying 3 to some power equals 27, so 3 to the first equals 3, 3 to the second equals 9, 3 to the third equals 3 times 3 times 3, which is 9 times 3, which is 27, so x has to equal 3. And that's all well and good because we had an x right there. This one we can kind of brute force. We can plug in numbers and we can figure out what happens. But what happens when I say 64 to some power equals 4? Well, 64 to the first equals 64, which is already too big. 64 to the negative first is 1 over 64. What about like fractions maybe? Like 64 to the something, 1 over, I don't know, like maybe it'll give me 4. So here's what logarithms are for. So logarithms are log for short. Instead of writing out logarithm, we just write log. You've probably seen that in calculators before. And it's just a quantity representing a power, stuff in the exponents, to which the base must be raised. The base being that number at the bottom, just like our base for our exponentials, that number at the bottom being raised to some power, to produce a given number. And they're written like this. So if you have some base represented by b to some power that equals your some answer, right? We can write that and go both ways and go back and forth. So this is an exponential form because it's got an exponent. We can write that as log with a little b for a base of the answer is our exponent because log gives us an exponent value. So we take the base is a little b, it just shifts down, of our answer equals the exponent because we're quantity representing a power, which don't forget power just means exponent here. So this is an exponential form. This is in log form. So the first thing we're just going to do is go back and forth. So we are asked for A, B, and C here to rewrite each exponential in log form. So we're asked to rewrite 2 to the x equals 4. I know this looks familiar. We've seen it up there. All we're doing is instead of writing it in exponential form, I want you to write it in logarithmic form. So we're going to write log first. The base is that number that the power is being raised to. So 2. Of my answer of 4 equals the exponent. Same thing for part B. Log of the base, so log base 3 of my answer equals my exponent, equals my power. Same thing for this one. And we'll worry about how to solve these in a later version. Right now we're just worried about going back and forth. We're going to say log of my base of the answer equals my exponent. And I've been saying this kind of weird, so let me just write down how you're supposed to say this. So you're supposed to say the words log base, example for the second one, 3 of 9 is or equals 2. And that's how you're supposed to say that out loud. So log base 3 of 9 is, or you can use the word equal if you want to, 2. Okay, so let's go backwards. So rewrite each log in exponential form. So instead of writing them in the log form like they're currently written, we're going to write them in exponential form. So our base b to the x equals a. So we need some base, we need some exponent, and we need some answer, right? So our base is the little number. Our base is that small number at the bottom there. Our exponent is our answer, equals that number that's left over. So equals 27, our answer. So we're going to say log, not log, we're going to say 125 is our base. Our exponent is 1/3 equals 5. And then this is a true statement. If you were to type in 125 to the 1/3 power and put 1/3 in parentheses, you get 5 as a result. Okay, last part, part F. So we need our base to our exponent equals our answer. Okay, so I did things on purpose here. I made sure to use a positive number, a negative number, and a fraction. And those are the kind of numbers you have to use when I ask you to solve for it. So if it's in logs and that's a problem for you, rewrite it in exponential form first. So our base is 2, our exponent is our answer, equals, okay, so base 2 to the power of x equals 32. So I know that 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I can say that x has to equal 5 because 2 to the 5th power equals 32. That one's pretty straightforward. Okay, so I don't like this in log form, so let's just rewrite this in exponential form. So 5 to the power of x equals my answer. So 5 to what power equals 125? So 5 times 5 is 25. Times 5 again is 125. Okay, so x has to equal 3. Fantastic. Alright, that one's pretty straightforward. Okay, so log of my base is 16. It looks like my exponent is x equals my answer of 4. So I'm going to look back up here when I converted, I had true statements because they were set up nicely. It looks like I'm going from small number to big number, I need to have a positive. But if I'm going from big number to small number, I need a fraction. So we need to say 16 to some power equals 4. So I'm going to try 1/2. If you type in 16 to the 1/2 in your calculator, that's an EV4. But if that didn't work, you could try like maybe 16 to the 1/3 would give you something else, or 16 to the 1/4 would give you something else. So it looks like x equals 1/2 here, because 16 to the 1/2 gave me 4. So if we're going from big number to small number, we need a fraction. Okay, so it looks like if we're going from a base to a fraction, we need a negative number. So we're going from a base to a fraction, so 2 to the x has to equal 1/4 for my last example. So I know that 2 to the negative 1 is 1 over 2 to the first, which is 2. 1 over 2, which is 1/2. So let's try 2 to the negative 2. So it's 1 over 2 to the power of 2. Remember how we just moved this from the top down to the bottom? We changed the sign of the exponent. So 2 to the second is 4. We keep the 1 as it is. So it looks like our answer, our x has to equal negative 2 because 2 to the negative 2 gave us 1/4 as the answer. And so here's the thing. If you're a little bit stuck on these two right here, we will use some log rules in the future to make this a little bit better. But for right now, just try plugging numbers in and seeing what works. And try to find a pattern. So small number, big number, use positive numbers. Small number to fraction, use a negative number. And then big number to small number, use a fraction. Okay, don't worry about memorizing those rules. We're just trying to plug and chug, see what we can get out of it. We will come up to the next one. Our next video is going to talk about how we're using logarithms to solve equations like these. There's some log rules. But for right now, let's just practicing on logarithms. I'll call this worksheet part A. So just going back and forth and doing some simple solving. That's just going back and forth between exponential and log and trying some simple solving. Okay. All right, folks, let's get to it.